Welcome to 3 Steps to Sketch. Today we're going to graph a shifted cosecant function, y equals negative cosecant of x minus pi over 4. So in case you're not familiar, here is the general form for a shifted cosecant equation. It's y equals a cosecant bx minus c plus d. So you can see that shift is happening in with the x. We have a horizontal, or what's called a phase shift. And it is following that bx minus c form, so this is the template that we'll use as we use the 3 steps to sketch method to get a good graph. So let's dig in. Here is our outline for our method. So remember, in step 1, we'll really do the bulk of the work. We're organizing and analyzing, finding our companion equation and the essential information. Remember, a companion equation for a cosecant graph is going to be its reciprocal sine graph. We'll get more into that in just a minute. In step 2, we'll plot that companion pattern lightly and go ahead and take care of the shift. And in step 3, that's where we create our reciprocal graph. So we'll recip, sketch, and repeat. And here is our equation again. All right, so starting step 1, we write our companion equation. All you need to do is replace the cosecant with sine. So we're going to be analyzing y equals negative sine of x minus pi over 4. Okay, and once we graph that, we'll be able to change it over into its reciprocal function, which is our cosecant graph that we want. All right, so identifying a little bit of information for this base graph. A, we know, is the coefficient out in front of the sine function, so that's a negative, meaning -1. I like to put a star here since I see that negative sign. A negative indicates a reflection of the graph over the x-axis, a vertical reflection. So that'll be important in step 2 when we start plotting the base pattern. All right, B is the coefficient of x. In this case, it's an understood 1. That tells us we should have one cycle of our graph between 0 and 2 pi. And we also use b to find the period. Do 2 pi divided by b. So in this case, 2 pi divided by 1. The period is 2 pi, or the length of one horizontal cycle. All right, now we can get some scale labels going. In this method, I always take the period and divide by 4 to get the horizontal axis scale. So take the period 2 pi, divide by 4. That simplifies to pi over 2. And I do that because in step 2, when we're plotting the companion pattern, we're going to have 4 key points, and it's really nice if that starting graph aligns nicely with horizontal tick marks. It just makes everything a little bit neater and a little easier. All right, so the vertical scale, 1 usually works really well. And let's go ahead and label our axes here. So counting by pi over 2 on the horizontal axis, count 1 pi over 2, 2 pi over 2, reduces to pi, 3 pi over 2, 4 pi over 2 reduces to 2 pi, and 5 pi over 2. Now take a second, go in the negative direction. It'll be all the same values, of course, just negative. So that doesn't take too long. And then you can go ahead and label the vertical axis as well. So counting by ones. All right. So now we have our grid set up, and we're ready to move on to identifying our shifts. So C over B will give us our horizontal or phase shift, and D would give us our vertical shift. So we'll go ahead and say we see nothing out past the parentheses to the right of the parentheses. There is no vertical shift in this particular equation, so we don't have that to take care of. You do want to take some care when you calculate C over B. Remember, we said y equals a cosecant bx minus c plus d. So we're looking in our function. So whether it's cosecant or sine, we can be looking in our companion equation right now. You want to make sure that it has the minus sign there. If not, you'll want to rewrite it, or at least mentally rewrite it, so that you know you're pulling the correct value. So for example, in this case, our c is positive pi over 4. And of course, b, we've already stated, is 1. So just check that minus sign, make sure you don't make a careless error. So positive pi over 4 over 1, that means we're moving right by pi over 4 units. Or notice on our grid, it'll be 1/2 of a grid mark. All right, so the last bit of analysis for step 1, I like to go back to the actual equation, so our cosecant function, and find the equation for all the asymptotes. And to do that, remember all you have to do is take the inputs of your cosecant function and set them equal to 0 plus pi k. 0 plus pi k are where the asymptotes are found for the parent function, just cosecant x. You can also think about it as that would be where the zeros are on a sine x function, but that's something that's really helpful to know. So a quick little calculation here, we have x minus pi over 4, those inputs, equal to 0 plus pi k, where k is an integer, and you'll get a different asymptote depending on what you plug in for k. And then all you have to do is solve for x, so simply add pi over 4 to both sides. And you'll find your asymptotes equation is x equals pi over 4 plus pi k. That pi k term is not like with pi over 4, so you aren't adding those two together. You just add the 0 plus pi over 4. So this right here is our asymptotes equation. And for example, substituting k is 0 is usually the easiest one. And we should be expecting on our final graph an asymptote at pi over 4. Subbing k is 1, simplify, we should have another asymptote at 5 pi over 4. Let k be negative 1, you should see there will be an asymptote at negative 3 pi over 4. I like to go ahead and find this equation. Sometimes that's all you really need if you aren't actually graphing the equation. But if you are graphing, it's a great way to double check your final graph. All right, so we've done a lot of the analysis and setup. We're ready for step 2. Let's plot this companion pattern and then we'll shift it. So make sure you're using a different color or marking lightly. This is not our final graph, but it's sort of our helper or our companion graph. Also, don't forget we have this negative 1 from our analysis in step 1. So we're going to be plotting our basic sine pattern, which typically is a 0 starting at the origin, maximum, another 0, minimum, but we know that this pattern has a vertical reflection, so it will go 0, minimum, 0, maximum. Okay, so marking lightly starting at the origin, you start with a point, again lightly on the origin, then we're going to move down to a minimum, and that'll happen at your first horizontal tick mark, and the y-coordinate's just the value of a, so that negative 1. All right, then you have another 0 at the second horizontal tick mark to the right, and then your final point will be a maximum at the third horizontal tick mark, and the value for the y-coordinate is simply the opposite value of a, so 1. So now we have the base companion pattern, and we're ready to tackle the shifts. So in this case, we just had that one phase shift to the right, pi over 4, or half a grid unit. So take each of these companion pattern points and shift them right pi over 4. So I'll mark that with an X, and we're still marking lightly here. Okay, so now this is our new intermediate graph, and we're ready to move into step 3. So we aren't taking literal reciprocals in step 3, that's why I have it in quotation marks. With this method, you just need to know which original point, which one translates to which new point on your final graph. So let's start with our original 0, that's now at pi over 4, comma 0. Okay, all the zeros from the original companion graph become vertical asymptotes. So we start with a vertical asymptote here. Okay, then your minimum from your graph, that's the one at 3 pi over 4, negative 1, that becomes a local maximum. Okay, so we'll draw in our curve in just a moment here. We have another original x-intercept, so that becomes another vertical asymptote. Notice we're working from our x pattern here. And then this maximum, what was a maximum, becomes a local minimum. So let's sketch that cosecant curve in. Okay, and we expect another asymptote over here. And we have one cycle of our graph. Before we repeat this pattern, notice that these two asymptotes that we've sketched in for this cycle of the graph are ones that we predicted with our asymptotes equation. So when we let k equal 0, we got this asymptote here at pi over 4. And when you let k equal 1, you get this asymptote at 5 pi over 4. So now let's simply repeat this pattern. We're just between these labeled tick marks. If you wanted to go back and actually label by pi over 4, you could. I don't think it's necessary for this particular graph. I think the scale we set up works well, but that is an option if you would like that. So we know we'd have another local minimum here, just sketching in that partial. And then let's work the opposite way. We'll work our pattern backwards, so we have a local minimum here, a vertical asymptote. Notice this one's at -3 pi over 4. We predicted that. That was when k equaled to -1. Not switching colors there, but that's what we have. All right. So then we have another local maximum, another vertical asymptote. You could sub in values for k. I'm sure you're predicting that would be when k equals -2. But there we have several cycles of our graph. So we'll sketch this in. So we have almost 3 full cycles shown here. You can still use all of your other double checks. We talked about the asymptotes equation already, but you can go back and check B, see that there's still just the one cycle happening between 0 and 2 pi. B is 1, that's what we would expect. We have a really nice graph here. Now, one thing to note before we finish up, if you know the parent graph y equals cosecant x, for a transformation like this, it is probably a little bit easier to just use your knowledge of transformations and reflect that graph over the x-axis and shift it right pi over 4. But this method, I think you find a lot of other information, you practice your analysis, and it helps when you get much more complicated transformations of the cosecant function. But it is worth noting you can do it that way as well. All right, well, thanks so much for watching this. I hope it helped you graph cosecant graphs that are shifted. I'll post some links in the video description, so check those out. There will be more examples of graphing cosecant, finding asymptotes of cosecant, as well as graphing all of the other trig functions. Thanks for watching.